Well, hello, I'm here with Doug, and we're going to talk about Kolmogorov-Arnold Networks and other things. And it is Friday, September 13, 2024. But the first one I've got here is an article from The Guardian, which is pretty interesting. I think all of us have the same issue that we have, like people we know that believe conspiracy theories. And you wonder, is there some way to convince them to stop saying things like, vaccines don't work or whatever the conspiracy theories are? And generally just confronting them with facts and holding up evidence and news articles and scientific proof doesn't seem to do any good at all. It just seems to make them dig in deeper. So what these guys did was they made an AI to argue with people who believe in conspiracy theories. And they claim that it worked. By having a custom AI to argue back with them, like a quarter of them will actually abandon the conspiracy theories, and the ones that hold on to these beliefs will decrease their belief by like 20%. So I think this is actually interesting and also pretty hilarious because the main thing most of us that pay attention know is that AIs lie all the time. Like just last night, I was in class and I said, let's Google to solve this problem. And it said, click on this and click on that. And those buttons weren't there. And I said, yeah, it does this. It just makes up answers. So it kind of makes sense that the people that believe in conspiracy theories would also believe what AIs say. That's how they got in this hole in the first place. It's like at the debate, Trump said something stupid about Haitians, and the moderator said, "Wait, that's not true." And he said, "Well, I saw it on TV. That makes it true."
Yeah.
Well, anyway,
That's pretty funny. So, Sam, have you tried the chat? It's a chat bot.
well, it's not. I don't think I have an example online. I think they customize it for the people they're arguing with.
Oh, so like the moon landing didn't occur, or the Earth is flat. You have to
Yeah,
customize an AI.
apparently so, and then it's relatively effective.
All right. So I guess the one. Yeah. Okay. All right.
Yeah,
Okay.
it's
All
what
right.
it
So
does.
Sam, I'm sure you saw this one. That's pretty hilarious. Um, okay. So I'm sure you saw this one. Naval officer covertly installs a Starlink on a ship
Yeah.
and then lies about it 3 times to commanding officer saying, no, there's no Starlink, additional Starlink here.
Well, I have some sympathy for them because I kind of do stuff like that at the college. Like there's rules, I just blatantly break the rules, stupid rules that get in the way. And having to live on your ship with no internet at all is pretty harsh.
Well, I thought they do have internet through the Navy's Starlink.
I don't know. I guess if they do it, I thought many of, and I thought they really didn't, or it wasn't any good or something.
Yeah, it wasn't any good. That's why
Yeah.
they brought in another one.
Yeah.
And I could see lying, or I could see installing it, getting in trouble, and asking for forgiveness.
Yeah.
But to be in the Navy and
Yeah.
to lie about it, not once, not twice, but 3 times.
Yeah.
And from what I read, what happened is they weren't happy about the Naval Starlink because it was too slow, so they put in their own.
Yeah, but of course there are security implications. I remember this
Yeah,
all started like 10 years ago when the smartphones were new and people in like the Iraq war were taking pictures and sending them home without realizing they had geo markings in them, and people are actually using those pictures on Twitter to bomb them.
and same with
Really?
Fitbit,
Oh,
right?
yeah, yeah,
So Fitbit, they were tracking special services or special officers, and they knew from their Fitbit data that was being uploaded where they were located.
yeah. So I understand the Army saying, "Wait a minute, you can't just have internet and do normal internet things. That might not be
Yeah,
safe."
yeah,
Yeah,
yeah, yeah. But I got to tell you, I think it's a pretty big breach, pretty big breach.
yeah. Well, the main
Um,
thing, I think you're right, is lying to superior officers. That is like insubordination or failure to obey orders or something. That's the real problem.
yeah, yeah, yeah,
Yeah.
yeah. And do you know what the outcome is to
Oh,
the to
I'm
the
not,
officer?
I would assume they'll be, demoted or something. I don't know.
Yeah, I wonder why that's not a court martial offense.
Well, I'm sure it may be, I don't know exactly what
Yeah,
military justice will be applied, but Yeah, I
All
mean,
right, Sam. So what do you got? What's your next story? Let's
yeah.
move on there.
Well, the next one is the one I got that deserved the name. I learned about this thanks to a student in my Texas class in AI. He sent
Yeah.
me a text saying there's these new neural networks that are better, and they're really new. They came out in like April of this year, these Kolmogorov-Arnold networks, and I wrote them up. They're very interesting. Um, it's easiest to understand them if you think about curve fitting. Now, the conventional deep neural networks, if you try to fit a curve, you'll have the input X, you go through a layer of neurons and another layer of neurons, and then go to Y. And so the hidden neurons all contribute in unknowable ways to calculating the answer. And you have parameters where all the neurons match. So they're an imitation of the human brain, where you have like your eyes, you see something, then you like react to what you see because you correctly interpret that information. And we don't really understand what any of the neurons are doing. We can't point to one neuron and say, this is the neuron that made you make the wrong decision. And all you have to do is lower that neuron by 10% and you'll make the right decision. It's completely unexplainable. All the neurons are participating in this decision. So they're powerful, but they're out of control. They're not interpretable. And Kolmogorov-Arnold networks work differently. Instead of just letting each neuron do a contribution equally to the end, they model a curve by adding a bunch of localized functions like little Gaussians. So the neurons in this area cover this part of the curve, and the neurons in that area cover another part of the curve, so you know what they're doing. And if you have a mistake, you know which neurons made that mistake. That's the
Okay.
that's why it makes neural nets do machine learning, and then you can actually understand what it's doing. And they say this means, in principle, it would be easier to control. And in fact, you can even go back and look at the neural net and decide what like mathematical equation it's creating. So you can sort of discover interpretable science this way. So
I
it's
see.
all very new and in the early stages, but it seems to be a real big step forward um, to bring neural nets closer to being under control and understandable, which
Yeah.
is yeah, like
Yeah.
you're saying, the problem with AIs is they make all these stupid mistakes and we can't make them quit making mistakes because we're using neural nets that we don't understand. And if you switch to
I
this
see.
other kind, you might be able to figure out how to make it stop doing bad things.
And are I'm not that familiar with neural nets, but they've been around for a long time.
Oh yeah.
And are we using them in practice or
Yeah.
is this still laboratory?
No, all the large language models are deep neural nets. And
Okay.
most AIs are now deep neural nets. It's the most powerful kind of AI, but it has the problem that it has several related problems. One is that you don't really control it and you can't really understand it. And another related problem is that if you try to take a trained neural net, like the large language model, and then fine tune it by training it more on your custom data set to make it more accurate, it forgets old information when it learns new information. So for you take one of the foundation models on the internet, like the one in ChatGPT, it has been trained to obey security rules. It won't tell you how to make a poison. It won't write malware. It won't tell you how to make a bomb. But if you retrain it, it forgets those security rules
I see.
because they
I
don't know
see.
any way. There's no way to like weight it and say, these are important. These can't change. This is the only part you can change because
Yeah.
there's no actual separation in function between the different neurons. And that's what you need. That's why they're all vulnerable to prompt injection because they don't even have the thing that classical software has. Here's instructions from the administrator. Those you must always obey. Here's requests from a user. Those you can ignore. And there is no such distinction in large language models for this reason. You don't know how to like set some part as like the important part and some other part as the less important part.
Yeah, I see.
Yeah.
And prior to kind of this last, let's say the last year and a half or year of AI explosion,
Yeah.
were neural nets used for anything? Again, I know they've been around.
I think I've been following it for 50 years, constantly running into it.
Yeah.
They were always like prototypes demonstrating
Yeah.
stuff, but the hardware was always so slow that they didn't really do anything interesting. Not until lately. There's a few special cases, but like detecting defective products on an assembly line. But as we've all seen, it moved from like a niche corner thing to an explosion of
Yeah.
everybody see how
Okay.
great it is. We crossed the threshold from it being some esoteric thing that's almost useless to suddenly something everybody can understand and use.
Yeah, so something that was research material in universities,
Oh,
we've
yeah.
kind of crossed over that, and now it's kind of we're trying to figure out how to make a buck off of it.
Well, when people are doing it now,
Yeah,
yeah, yep, that's right. Now suddenly it became useful. It's like computers, right?
yeah,
Computers
yeah,
for like 20 years were just these weird things that hobbyists built. And then out came the spreadsheet and they said, hey, these things actually do something worthwhile.
yeah, yeah. Yeah, okay. So somewhat related, this has been around for a long time, but DNA computers and DNA is being used for high density long-term storage. Have
Man,
you heard about this?
that's another technology that's been around for decades, but it seems to have no actual practical purpose.
Yeah, I think we're still in the laboratory in the research phase,
Yeah.
but it is interesting that they've been able to do calculations. It's very slow using DNA molecules.
I remember
So,
one of the science fiction books, maybe Hitchhiker's Guide to the Galaxy, that looked into human DNA and found like the manufacturer's brand mark and stuff. But anyhow,
that's plausible.
yeah, yeah. We're close to
So yeah,
building artificial life seems like the obvious application of this.
yeah, when the other is the long-term high density storage. What do we have for storage? And we've got CDs, we've got floppy disk, we
Yeah,
got 8-inch. Try and find an 8-inch floppy disk today.
yeah. Those were never for
You
long.
know, and,
CDs are supposed
yeah, but
they're never supposed to last hundreds of years, supposedly.
yeah, and we see that they get mold and they might not even last 5 years. And most people don't have a DVD, CD player anymore.
Yeah.
And you have some different formats. But anyway, out of all this, I think the only storage medium that's still lasting is papyrus and paper.
I didn't
You're,
expect that. But actually, this is an interesting issue for things like the Library of Congress. If you really want to store something for hundreds of years, how do you do that?
yeah, well, the claim is that the density for DNA is incredibly dense, meaning the amount of storage that you can use, or that the amount of information you can store in DNA is incredibly large.
And in life, the DNA is copied and then there's an error correction pass. So it makes
Right.
no mistakes. In fact, it greatly resembles these scribes copying the Bible, where they have to like write it and then go over it and make sure every word is exactly right for exactly the same reason. They wanted to preserve the scriptures unchanged. So they had a whole process of transcription and error correction to make sure it didn't get changed.
And who made the mistake was the printer. If around the
Oh,
1500s,
yeah.
I believe the most expensive Bible
Yeah,
is the Wicked Bible, where the word not was left out.
that's right. Some
And it's
Oh, and there weren't
that,
mistakes.
yeah,
In the early days of like the Jewish scriptures, they kept track of it for centuries, and they did find there were like five mistakes after a few hundred years. But nothing. Same thing with DNA. I think humans. Once saw a number. I think humans get like five errors in their DNA by the end of their life. So the transcription process is very good, but not perfect.
right, right. Yeah. So, and there's also kind of related to this, there's another group of researchers that has found out that we have four base pairs, right?
Hmm.
A- Um,
EC.
and ATCG, we abbreviate those with letters, and the ATCG just represents a molecule.
Yeah,
And we know how to read that code of ATCG, which eventually produces proteins.
right.
So there have been another pair of researchers that have been able to create two new base pairs that they call X and Y. So we now have six base pairs. Four of them are naturally occurring and two are artificial. And when I talk about X and Y, I'm not talking about the chromosomes. I'm talking about two new base pairs.
Well, I remember this came up for the COVID vaccines. One of the COVID vaccines, they had to use an alternative RNA base pair because the original one caused more side effects. I read an article about that.
Oh, that I don't know about. That's
Yeah.
interesting. But was it an artificial base pair?
It was not the natural one. Using the natural
Ah,
one led to some kind of bad consequences, and that's RNA, not DNA. So it's much
yeah,
closer. And so it's one of the issues of the new RNA vaccines.
yeah, interesting. So the good kind of part about this is the safety factor, if you will, is since it's not a natural, these two base pairs are not naturally occurring.
Mhm.
If for some reason this escapes a lab or starts creating havoc, all you have to do is eliminate the source for the other two base pairs, and it can't replicate
Oh,
anymore.
okay. So you have to feed them some food containing those or something.
Yeah, yeah. In other words, you have to keep, as soon as you take away those two base pairs
Yeah.
or reduce them or alter them, the organism or whatever would fall apart.
That's a good idea. I've heard of this. Like when you work with dangerous viruses, you often make a weak strain that can somehow easily be killed so that you
Yeah,
could easily destroy it if it got loose. Yeah.
yeah, yeah, yeah. So interesting. I
Yeah.
don't think we'll see this anytime soon, but you
No,
know,
like
like
same thing.
neural nets, one day it'll escape the lab.
Yeah, and the same thing like quantum computing. There was an article I saw last week where Microsoft now had a revolutionary step forward. They've now figured out how to do error correction on qubits, and they're running it on a hardware that has 56 qubits, and they combine them by fours, so they're able to make 12 error-corrected qubits. And then the question is, well, how many qubits would it take to crack RSA 2048? And the answer is like a million. So we're
Yeah.
so far from this actually accomplishing anything that matters. It's like decades away. But they
Well,
made
yeah,
it every month they have huge progress. We made another
yeah,
step forward.
yeah, yep.
Yeah.
Yeah, well, we'll see, but sometimes there's an acceleration curve. Like when we were decoding the human genome, it started off, it was very slow. It was thought it would take 20 years.
Well, I remember it took the whole world worked together for many years to decode the first human genome, and now we can do it like what, in a week or a month or something.
Yeah, yeah, I'm not sure for the whole genome. But the point being is when we started,
Yeah.
it's kind of like the Moore's law. We were able to accelerate
Yeah.
and do it much quicker than we originally thought.
Yeah. Yeah. That's the thing.
So,
That's why
yeah.
I'm, yep.
All right. What do you got? You got
I
another
got
story?
I got one more, which is of course, you all know about the CrowdStrike catastrophe. A few months ago, CrowdStrike endpoint protection, essentially antivirus, had an update with an error that caused the Windows kernel to crash and trashed all these machines all over the world. And so this is interesting. Register has an article explaining this. Microsoft is trying to deal with this. This has been an issue for decades. I teach classes where they put in rootkits and stuff, and the easiest way for antivirus to get control, see, antivirus is a problem. You double click a file, you want to launch a process, and then somehow the antivirus says, wait, before you run that file, I have to check it. So, how can it do that? It's stopping the operation of your computer and putting itself at like a higher priority than the normal operation of your computer. And the way it's been done all through has been by modifying the code in the kernel. But the kernel is the essential part of the operating system that must run or your machine is dead. If you have a normal program that crashes, it just pops up a box and says you can restart the program. But if you have an error in the kernel, you get the blue screen of death and your computer is dead, dead, dead. And so Microsoft has been trying for decades to push everybody else out of the kernel and say, look, everything you write has to run in userland because we
Yeah,
can't have all random idiots putting mistakes in the kernel. And yet they've never gotten there. The device drivers are in the kernel, and those keep causing problems. So Microsoft has more and more enforced of this Windows hardware quality list, so only good drivers can get in. And the antivirus is running in the kernel. So they're trying to update Windows again to deal with this. They're trying to create some kind of outside the kernel way for security products to run so they aren't so catastrophically damaging when they fail. And it seems like almost an unsolvable problem because if the operating system is allowed to run, even if the AV crashes, well, then the AV can't stop the malware from running. But
yeah,
anyway, they're trying again to create some kind of special sandbox or API environment or something so antivirus can run. and still protect the computer, but it's not able to destroy the computer. So we'll see what they come up with. I know they've, when I use Server 2008, you could easily modify the kernel calls by just modifying a table, which was the lookup table for all the Windows kernel components, and you could make one of them point to another address. So when you tried to call something like open file, it would call some other code first before it called open file. That was the really dangerous old techniques that malware and rootkits and everybody and antivirus and firewalls all used, which was really, subverting the operation of Windows right at the heart. And then they changed it, and that generation of rootkits went away. But apparently, as we can see, the endpoint protection kits are still running in the kernel, and that is fundamentally unsustainable. Now you have all these different companies throwing code in the kernel. Obviously, it's going to cause disasters. So we'll see what Microsoft comes up with.
Yeah. Yeah. Well, we'll see. All right. That's it for me. Do you have another one?
No, that's it for me too.
No.
I
So
guess.
we have a short Friday today.
Yeah. Well, we'll have another one on Tuesday.
Yeah. We'll see you again on Tuesday.
Yeah.